Uh, Before the speech, I want to just read how many people use Rocket in development progress or production environment. Please raise your hand. Okay, just like I thought, a few people use the Rocket. Maybe a container will be help us is the first step using and trying Rocket. Besides, Registry is the most important reason the Docker becomes popular and successful. It's a long story about the container registry concept born, and I will make quick. And if you have any questions, we can talk at the lunch face to face. I'm Quanyi Ma. I'm from Huawei. I'm a senior architect and a stack developer. I paid attention to Docker and container technology as early as 2013. Since then, I spent a lot of time and efforts to encouraging Docker community in China. I organized the Docker meetup, CoreOS meetup in Beijing, Shanghai, and other cities. Golang, DevOps, AngularJS is other interest. I propose a container ops, which is a new DevOps concept, and I'm building an open source toolchain for this. You can reach me with the email and the Twitter account. Before the Docker became the most popular choice, most people use the LXC, which is Linux Container Project abbreviations. Why use the Linux Container Project and not just call namespace and C group from the kernel directly? Besides, the namespace and the C group is the original technology base of the container. It's another long story. It's not subject today. I think Linux Container Project has a more friendly interface for better than calls API from the kernel. The developer could use the Python binding, Golang binding, even Ruby binding. And the Linux Container Project has a mechanism named template. The developer could start a container through the template, which is already customized the environment, which it looks like a complete Linux system. So we call the container is system container. The Docker released the first version at the March of 2013. The initial phase, Docker just the framework of the Linux Container Project, but the Docker improved the interface further. From the first version, Docker provided the REST API interface, so the developer could call the API through the Unix socket or the proxy of the nginx. The developer could use any programming language, even curl command in the bush. Another big thing is Docker used AUFS, Advanced Unified System, or another unified system. AUFS is a unification file system. It means it takes multiple dictionaries on a single Linux host and stacks them on top of each other and provide a single view. To achieve this, AUFS uses Unimount. Within Docker, AUFS Unimount the image layer. So the template of the Linux container project, Linux container becomes the image layer of the Docker. It's a smaller and versioned and scalable. It's an amazing thing. So and it is more focused on the application. So we call it application container. Make the Docker popular is a shared system. It's a Docker registry, then later call name to the Docker Hub. The developer could share the experience through put them into an image. If the developer share the code with each other, she must be share the documents, menu, even the make file, help the user how to build and how to use. If the developer share the image, the user can run immediately. The spread speed is celebrated. Now, the Docker Hub is a second community in the developer world. It's a powerful and promising, but I think Docker, the GitHub is still the first one. In the Docker Registry 1, Docker client pull an image is complication. First, the Docker client will ask the Docker index for the token and the endpoint. Then the index return all the information to the client in the HTTP header. Then the Docker client access the Docker registry of the endpoint with the token. The token verified between the Docker index and the Docker registry. Finally, Docker registry return all the data or URL to the Docker client. Usually, Docker registry use object storage service to store the image layer. So we have a built-in object storage service in Dockyard. I will take a talk later. In Docker Registry 1, the Docker index is not open source, and the Docker registry is open source but developed by the Python. It's very different between the Docker, which is developed by the Golang. So we decided develop our registry, Dockyard, with Golang. We choose a web framework named Macaron. It's a practical web framework. It's developed by my friend, and it's delicious. Yeah. So it's the router define about the Docker Registry 1, and we implement all the handler function by ourselves. It's the biggest between the Docker Registry and the Dockyard. We store all the information and the metadata into the MySQL database. When Docker released the Docker Hub Enterprise version, so everyone know why the Docker Registry is so simple. It's just a business. In the period Docker Registry 1, the incompatibility between the Docker client, the Docker index, and the Docker registry open happened. But it won't stop Docker become the most popular project in cloud computing and open source community. But Docker is not only option. CoreOS released the Rocket at the fourth quarter 2014, and CoreOS bring a specification named APPC, Application Container Specification. It includes Application Container Image Specification. It contains all the files and the metadata needed to execute an application. The unindexed layout of the application container image is straightforward. It has rootfs dictionaries, include all the files on top of the application, and a manifest file describing the content of the image and how to execute the application. The OCI file format aims for flexibility and relies on the standard and common technologies like HTTPS, GPG, GZIP. It makes it easy to build host and security. The image file is addressed and verified by a hash of uncompressed file, tar file. It's image ID. The image ID reference provide a V reference an image file. So it's an application container image discovery protocol. Usually use one or more template render the image URL and signature file URL. It must has be the .asc for the image file and .asc .aci for the image file and .aci.asc for the signature file. It's the router define about the application container image discovery in the Dockyard. So we have the two group in the router. You can use the Docker and the Rocket at the same time. And we extend the protocol for pull and push common software tar files. So the Dockyard is be the common software repository. I think application container specification is simple and compact. It's more pressure for the Docker. So Docker move on to the Docker Registry 2. Docker Registry 2 has a new registry named the Docker distribution developed by the Golang, but it's completely incompatible with the Docker Registry 1. And I don't know how this. The new registry is the goal is for provide the flexible, consistent storage location for the image storage, and minimal index for the fetch the image. It still has not a database driver for the index, so I think it's a simple index function and a complicated process. In the Docker registry one, the Docker calendar will be access the Docker registry directly for pull or push an image. The Docker registry will return the HTTP code 401 if they need authorizations. So the Docker calendar will be access the authorization service for a bearer token. When he get the bearer token, they will be access the registry again. Then finally the registry return the image layer data or the URL to the registry like the Docker registry one. The Docker registry 2 provide the endpoints for add the function like a search, index, explorer, but I think we need an all-in-one solution. So we implement the functions in Dockyard, and we are working on the Huawei internal system. So when we ready, will be open source. It's the router defines about the Docker registry 2. So there will be a 3 router group in the Dockyard. You can use the Docker registry 1, Docker registry 2, and Rocket at the same time. It's our version about the container registry. The OCI is the Open Container Initiative. The OCI project is tasking creating a software shipping the container image with the OCI image format. The OCI image format project intended to start with the Docker registry 2.2 and improve remain the technology concerns and improve the understood of the priorities of the format. It's the objectivities of the OCI image specification. A serialized image format, processing, hashing the image format, signature and naming for on the DNS. The OCI runtime. The OCI has another project. Is the OCI runtime project, certification project. It aims for provide a certification for life cycle running container. I think the OCI runtime project will be work with the OCI image format project. The OCI image format specification is, I think, it's a bridge. You could convert the bridge between the Docker image and the Rocket image, so you can convert one to another. If we can choose the format freely, we can choose the runtime freely. With the user use the container in the practice in the private environment, most developer or the administrator is facing to choose tools, automating deployment, scaling, abstraction tools, and not choose runtime. The Kubernetes is the best one. Is from the blog paper, which is from the Google use container in production environment more than a decade. In Kubernetes, the kubelet is a component of the Kubernetes notify the Docker daemon to pull image from the registry. Now the Rocket will be fully supported in Kubernetes, so the registry or Kubernetes should be supported both. I think Dockyard is the best choice. In this architecture, we think the best way is let the kubelet pull an image from the Dockyard directly, not notify the Docker or the Rocket. We can through the HTTPS, even peer-to-peer. We have a lot of discuss with the Kubernetes team. We are on this. Like I said, we have a built-in object storage service. Is a part of the SBD, which is from the Jingdong Cloud team. The SBD is a high-performance distributed Docker registry storage solution. It's easy to scale by add instant storage. So no data move on between the storage instance. There are a registry driver for the SBD. Is divide the image layer data to fix size chunk to upload and download. The image server is a state list to provide the REST API for the download and upload. The image server gets the chunk server information from the chunk master and the file ID from the chunk master. Then they decide which group to save the data. The chunk master is designed to maintain the information of all the chunk groups information and allocate the file ID. The chunk server uses the MySQL save the data and save a copy in the memory. When the image server will ask the information from the master, the chunk master will return the information from the memory immediately. Then the image server will ask the file ID with the chunk master. The chunk master will locate a continuous file ID to the image server. The chunk server usually use B to store the data and usually use the chunk group. Image server, usually the chunk group has 3 chunk server. Image server save the data success with the chunk server group means the image server save the data on each chunk server on the group. The Dockyard already integrated with the Clair is a static analysis with vulnerabilities, and it's from the CoreOS. I will talk about this because there is a session this afternoon. You can learn more information at this. Okay, finally we can talk the volume. A few months ago, we decided to develop a volume management in the Dockyard, and the first design is very simple. We put an agent on each node, allocate and destroy and back up the volume data for the Docker container and the Docker container. Then the agent collects the information directly with the Dockyard master. But I think we are wrong. Just like I said, usually people use the Kubernetes, and the Kubernetes already has the volume management. So we just integrate with the Kubernetes is fine. So we are working on a new volume management in the Dockyard with on high level on the Kubernetes. Our goal is accelerate the image layer distributed process and the life cycle of the volume data. In Huawei, we have our distributed file system looks like a Ceph. So we work with the team and we are testing on our internal system. When we're ready, we will be open source. Okay, that's all, and thank you for everyone, and thank you for the time.